Hi everyone. Yeah, today's talk is about LlamaIndex from basics to production, and a lot of interesting demos as well using LlamaIndex. Oh,
Just 1 second. I think online things नहीं आ रहे.
how is it?
This getting cut or something. So we are.
Okay.
Then it could be open chat Q&A also if you want. The side maybe. Yeah, but it'll be better. Leave it on the.
Yeah.
Okay, just leave it on the table. It works.
Am I audible now?
Yeah, that's good.
Yeah. Okay. Yeah, myself Ravi Teja, and open source contributor at LlamaIndex since almost 4 to 5 months, and also work as a data scientist at Glance in Mobi. I work mostly on recommender systems and building NLP applications and AI automated systems for helping content team to reduce their time at Glance. So today I'll be talking about the framework LlamaIndex, and then how can you build chatbots and various other systems using LlamaIndex, and how can what are the tools available to make productionize. To start with, let me set the context. LLMs are good. Yeah, as Sandeep said, there is a lot of use cases that he has covered. Code generation, doing generating some answer, and also text generation, summarizing something, or doing some tasks, or writing some blog post given some topic. It can do a lot of things, but there are two obstacles to it. One is the training data is capped at 2021, and then the context limit. So how can we solve that? There is one question, and also most of the LLMs are good, but I have I want something that can be done on my own data. The data is present in different forms like PDFs, audio files, which are raw files, or maybe in Notion documents, Slack channels, or else CRM enterprise levels things. Or my data is indexed in vector stores like Pinecone, Payviet, Milvus, or some other vector stores, or maybe data is present in structured format in SQL databases. But I want to make LLMs use this data and do some tasks for me, like question answering on text generation or summarization or something. One way is fine-tuning your own LLM, but it is pretty costly. Maybe you can use RLHF or any other techniques to use your own data and fine-tune the LLM. But the cost part is very huge, and again, most of them are instruction-based LLMs, and then so creating the data in the format of instruction-based is a bit huge challenge. As I said, it's data preparation error and lack of transparency. Probably you need to evaluate repeatedly how as you fine-tune the model, and the upfront cost. It's very huge. So one way of dealing with it is you have a lot of text in Notion document. Probably include that in your prompt along with include that in your prompt as a context along with your query, and let LLM answer it. But then one of the issues is you have probably GBs of TBs of data, and then again finding the of all the context available, like let's say 300 pages of book, and I index it, and finding the right context to answer is very difficult. And we have maximum probably 100K Anthropic model to include all the context, but 300-page document won't be effective in 100K as well. And also, if you want to go through entire notebook with 100K context and with 300 pages, it's pretty difficult. The cost is huge. So how can you deal with that, with the performance and latency and cost as parameters? That's where LlamaIndex as a framework comes into picture. It acts as an interface between your data sources, different data sources, and your LLMs. Your data sources and LLMs. So there are different kind of intensive applications that can be built in different domains like sales, marketing, and recruitment, developer tools, or legal finance. So LlamaIndex as an acts as an interface between different data sources and all this foundational model. So essentially, there are three components to the framework. One is data ingestion, and then second is data structures, and the third is retrieval and query interface. So for all these different data sources are present, like let's say raw PDF files, audio files, or Excel files, and as I said, Notion documents, Slack channels, and Salesforce CRM channels, or maybe vector DBs or any other data sources. So we need connectors to load these data from different data sources, and then do some indexing or querying or retrieval systems on top of that. So that's where Llama Hub, which is part of LLamaIndex, is an integral part of it. So it has different connectors like PDF readers, SQL data connectors, and then audio data connectors, Notion data connectors, different, almost we have 100 plus data connectors to it. So I'll go through each part of it, probably in the next slide. Yeah, to start with Llama Hub, yes, as I said, there are a lot of data, 100 plus data connectors, which can be useful for to easily digest the data, ingest the data, and then there's a lot of community support for Llama Hub, and it's very easy to even integrate some new connector to the to Llama Hub as well. So as you can see here, hardly some less than 10 lines of code. Here it's a Notion page reader where it can read the data from one of your Notion page provided your integration key of Notion integration key and page IDs, and then the documents will be loaded into an object. And then there is, once you load the document, you basically index it. There are other three components: index, retrieve, and query interface. So once you have documents, you need to basically index. What I mean by index is your chunking mechanism. So since your LLM can't be fit, the whole book, probably 300 pages, won't be fitting into an LLM. So we need to basically index. What I mean by index is you need to chunk the whole book into different chunks of, say, 2000 tokens or 4000 tokens based on the LLM context size you have. And then once you have indexed your data, there are two other components: retriever and query engine. So given a query, once you index data, you have an index, and you have an overview of your raw data in the form of vectors and keyword lookups or summaries or whatever in the form of index. So when a user gives a query, what it passes through the query engine. The query engine calls the retriever, which retrieves the most similar documents chunks in the whole book. And once it retrieves and let's say top two nodes or chunks, and then it gives it to LLM to generate a response. So that's what I gave a brief idea about. Let's speak about the basics data structure available in the LLamaIndex, which is vector store index, and the other one, list index, is something is an interesting one. I'll be covering the later one. So starting with the vector store index, as I said, there is Llama Hub reader, which reads all these documents, and then there is indexing happening. The primary structure of LLamaIndex is node. When I say node, you have 300 pages of document, and you basically chunk the document into different chunks. So each chunk is called a node, and each node has the embedding that is related to the information present in the chunk. So let's say, for an example, we just have 3 nodes present in it. So given a document, it just chunked into 3 different documents, and each node has the text information present in the chunk as well as associated embedding. So once you have 3 nodes, and I have given a query, okay, what happens is it creates the query embedding. You can use any open source embedding or else OpenAI embeddings or any other embeddings as well. It will generate your query embedding, and then it will based on, let's say, I want to use similarity top k equal to 2. It just retrieves top 2 nodes based on the embedding similarity, and it then goes to the gives the query and then retrieve nodes, node 1 and node 2, to the response instance module.
So there is one question, which is, does Llama store the context that we provide in some vector index by default?
I mean, LlamaIndex.
You just click on the Q&A. You slightly convoluted question, please.
Store the context that we provide in some vector index by default. No, the whatever document you give, it is stored in the vector index. And once you give a query, it retrieves from the vector index some chunks, and then those chunks are passed to the LLM. Yeah. So, and this vector index is in memory, so the whole control is in your hands basically. Yeah. Should I go to the questions or?
Maybe just finish your thing, then we'll take up the questions.
Yeah. Okay.
We can move it to one side. Okay.
Yeah, going to the response synthesis model. Yeah, one approach we have is create and refine. So we retrieve two nodes here to answer the user query or our query. And then given a query, we have LLM, let's say 400 length context. We pass the query and the node one information to the LLM and ask LLM to answer the given query based on the node one information. Then it gives an intermediate response, which is response one. And the final, and you even have node information in node 2 as well. So now for the second LLM call, you pass the query and then the existing answer that you got from node 1, and then even the node 2 information as well. And then ask LLM, hey, I have an existing answer which is an intermediate response. And can you update my answer for the given query along with the node 2 information corresponding to the existing answer. And then it generates an answer. Like here, there are only two nodes which have taken an example. So the final response is whatever the answer is being generated from the node 2. Let's say if you have like 5 nodes, the same structure is being repeated. Like you will have intermediate response 2, and then you'll pass intermediate response 2 plus query plus and then node 3 information to generate an answer. This is a recursive process, and if you have 5 nodes, after 5 nodes, you'll get a final response. That's how the whole response synthesis module works in LLamaIndex. Yeah, going to this is the basic structure of the LLamaIndex of the basic vector store index. So there are some interesting use cases that you can try it out. So the basic use case is semantic search. Hardly 4 lines of code. If you have everything, if the data is being stored, the whatever private data you have is stored in your data folder. You have a simple directory reader from Llama and which is including LLamaIndex. So, and you read the data and you pass the documents object to vector store index, and then it creates an index. Once you have an index, you basically are making it to use a querying purpose. So have query engine parameter object and then start querying. So here one of the questions is what did the author do growing up, and then just answer based on the loaded documents. And then there is other use case summarization. So in vector store index, as we have seen, we generally will be probably similarity top k equal to 1 or similarity top k equal to, or maybe 5 or 10, whatever, based on your experimentation or iteration of the answers you get. But there are some cases where you want summary of the book or maybe summary of let's say of the index document. So in those cases, you basically need to pass LLM to all the nodes or all the chunks available and then generate an answer. In those cases, we have list index. The default, what it happens is you make an index and then probably should, yeah, I'll take this example. In list index, what happens is you have let's say 3 nodes, node 1, node 2, node 3. And then if you ask what is the summary of this book, let's say present in 3 nodes, it will iterate over each node, node 1, node 2, node 3, and then generate a summary. It's like there is no similarity top k parameter by default. It just passes through the LLM calls happen sequentially through each node, and it will generate a final answer. Yes, one of the questions now which we generally receive is, can we use LlamaIndex with open source models? So here is an example where I process with GPT for all an open source model that can be run on CPU itself. So we can download the model and then with the local path, and we have a Jupyter for all wrapper around it to have the model, and then to use some embeddings which are open source sentence transfer more embeddings along with the LLM, which is Jupyter for all, and then build a service context that this is the embedding model and this is the LLM we are trying to use, and this is the chunk size and all those things, and build a vector index and start querying. So this is how hardly 10 lines of code, probably maybe 10 to 15 lines of code, where even with open source models, you can build some index and start querying. Yeah. So going forward, next use case, building a query interface engine. So often we use, let's say we want to have the user can have a query on summary of a document, or maybe a specific part of a specific, he wants to get an answer for specific question. In those cases, we have to use either list index or vector store index. You will use list index when you have a summary. You want the user wants to have summary, and you'll use vector store index when you want to retrieve some chunks parts of the book and then ask make LLM to answer the question. So in those cases, we have a router abstraction. You index your book, your document in your vector store index as well as list index. When there is a query, the router will automatically route it to different index. I mean, one of these two indexes. Let's say the question is about summary of the book, then it will route it to the list index automatically, and then start doing the responses and generates a summary. And if it is answering a specific question, then it routes it to vector index and then retrieves, probably if you do similarity top as top 2 or top 3, retrieves through those 3 nodes and goes through the refined synthesis module and generates an answer. That is one interesting application where you can index multiple documents and then have the router engine do its work based on the user question. Another interesting use case is, let's say I have documents indexed, multiple documents indexed. Here I have we have taken Uber 10K filings and then Lyft 10K filings documents. So maybe we have, let's say Axel has some 10 companies under it where it wants to compare what are the revenues probably across different companies, and all these documents have been indexed. Now I want to ask question something like compare revenue growth of Uber and Lyft from this 2020 to 2021. So to answer this question, we basically need what is the revenue growth from Uber and what is the revenue growth from Lyft. And once you get the answer from what is the revenue growth of Uber and Lyft separately, and we need to summarize those two answers and give a consolidated final answer. So for that, what we have subquery, sub-question query engine. What it does is, given a question, it automatically generates 2 sub-questions. So here one of the sub-question will be, as I said, what is the revenue growth of Uber from 2020 to 2021? And the second sub-query question is, what is the revenue growth of Lyft from 2020 to 2021? And then the first question will be posed to the index but on Uber 10K filings, and the second question will be posed to Lyft 10K filings. Once you get the answer from both those 2 indexes, it again synthesize the answer, concatenate it, and synthesize a final answer. What is the revenue growth on Uber and Lyft? That's how a query plan is generated, and then a answer is synthesized by using both the indexes. And then next use case is multi-step queries over document source. So often sometimes a question can be can't be answered directly. Probably maybe you need to decompose given question, get an answer, and then pose this next question to the index and then answer the given query. So here is an example who was in the first batch of accelerator program the author started. So to break the question, the first question can be, what accelerator program did the author start? And then the answer, a intermediate answer, which is the author started the accelerator program called Y Combinator. And then once you get this answer, the next corresponding question is, what was the first batch of Y Combinator's accelerator program will be? And then the final answer will be created. And then there is no next question that should be answered to give a final answer to it. So it just said none. This is the final answer. So the final answer is that has been generated over here.
But who does this query decomposition? This is the
So it is internally done.
internal LLamaIndex.
Yes, the framework has been.
Sorry, so you're saying that LLamaIndex will to figure out that this question is a good one. That's amazing.
Yes, yes.
I thought this was supposed to be done by like LLMs.
Yes, so internally, it's prompt engineering that we have done.
Oh,
And the next use case is temporal relationships. So let's say I have a document that is, let's say, in the healthcare system. I have some disease and I went to a doctor, and then the doctor prescribed some things to me, some medicines based on my condition. Today's condition, it's very critical, and then and then after 1 week, it was a bit better, and then he modified the medicines. And then third week, it was much better, and I want to have. I mean, the doctor says you're pretty normal, you don't need any medicines. So I want to have a query engine on these kind of documents, but still, so after every, and when I have all these 3 phases of documents in the healthcare system, so when I query it, the system can retrieve any of these 3 weeks chunks of document chunks, and the answer might not be right. So rather than that, probably we should retrieve the chunks based on the date information. Because if, let's say, after 3rd week, if I ask how is my health, it should be the answer should be you're very well. So it should basically retrieve the most recent document based on the date. It's maybe after 2nd week, if I ask how how my health is, it should basically just tell about what is, my health is getting better. So it should not take the 1st week healthcare system document, but it should take the 2nd week health report basically. So in those cases, and in some cases where something like this, what did the author do after his time at Y Combinator? So if you give a question to this document, probably it will retrieve a chunk which says the author did something at Y Combinator, but not what he did after Y Combinator or what he did before Y Combinator. But when you chunk the whole document in a sequence, right? So once it retrieves, let's say, the central node time at Y Combinator, the nodes which are present after this will tell what is he doing after Y Combinator time, and nodes before this might be telling about what is something he did before Y Combinator. So once given a question, it will retrieve the basic node, I mean the central node, maybe the time he did at Y Combinator, and then some nodes, let's say 3 nodes that can be that are post his time at Y Combinator. So, and also you can even ask it to retrieve before the time at Y Combinator. And then using all this, probably 6, if you give post and pre as 3, probably 7 nodes of information, it will try to answer what did the author do after his time at Y Combinator. Without this, temporal relationship thing, probably it might have retrieve only the central node, which is what did he do time at Y Combinator, and the answer might be irrelevant to whatever it gave. Yes.
But how is the data being distributed into nodes? Is it always basis time, or is it how it was in the original library? Because sometimes the data of time after YC might be stored in an earlier node. That is also done by LLamaIndex.
No. So here the document. Okay, the data example. I think I might have confused it. Let's say the data example. I'll go with later. But yeah, but here, given a document, it will be chunked in a sequence manner, right? And
sequences basically start with.
Yes. I answered your question again. Yeah. Okay.
Just a follow up on that. So the assumption is that LLamaIndex is assuming that the document is written in a way that it's defining temporal relationship as the sequence is progressing, time is increasing.
Yes.
All right.
And then, as I said, you can use the date filter, like in the health report system, which I have given as an example. So I have node 1, which is at probably 3/1/2023, and node 2, 3/2/2023, and node 3, which is 3/3/2023. So if I give a question based on this date filter, metadata filter, it retrieves the most recent healthcare report and tries to answer the question. That's how this recency filter will be useful. Another thing, most of the times, like there is a lot of personal information. Recently we might have there are some instances where GPT-4 has leaked some of the users' personal information as well. So before giving my query or my information to LLM, I want to mask all those personal information. So internally we have NER personal information node processor. So once these nodes are retrieved, let's say one of the node information is my name is Raviteja and I live in Bangalore. So my mail ID and phone number. So given this node, before sending this information to LLM, it first sends to the node processor, and then it masks, like, yeah, these are names, these are places, these are contact names, this is email ID, and some other things. So internally we use an NER model, or else you can even plug in your own NER model that is trained on your system in your own data, so that it will be more effective. That's how before sending LLM the data to LLM, we can even mask the data. And this is one interesting application based on this. Yeah.
Can you full screen?
Yeah. Yes. Yeah, before playing the video, I want to give set a certain context for this. This is done by Llama Readers team at Mumbai Hacks. So what they did, so often we read books and novels on Kindle or any other, probably any other digital platform. But I read probably a book for 10 days, and then I probably get bored, I leave it, and then I come back next month. Again, want to continue reading the book, but I might have forgot what has been done in these 10 days, first 10 pages of for these 10 days, whatever I read for the 10 days, probably 100 pages of my book. And I probably might have forgot what the character has done, what the character has done in the last few pages, or maybe what is the summary of the first 100 pages that I have read for the whole book. So these people have built a tool, LLamaIndex readers, wherein as you read the book and you stop at certain point, and then you want to get the summary of book, let's say after 100 pages, you just need to mark some some strings in the book, and then it just creates a summary from start to that point. Or else, if you want what happened to a certain character in the last few pages, it gives information about the character as well. So starting with the demo. So loaded a demo, a book, sorry. There are different chapters available in the book. So going to the 6th chapter probably. Just click like I want to know something on this screen. So you have 3 options: recap until now, or what has this character done in the last few pages, or fetch history of these characters, something like that. So here the response is like what happened till now, this chapter. And then even for the character Winston, probably in the last few pages. And then about the history of this character. Yeah, this is an interesting application that people have built using LLamaIndex and the node processors that have been discussing till now.
One or two questions, Ravi. One question is like on masking. How does LlamaIndex ensure that it's 100% effective?
Okay, so as I said, internally we are using a hacking face NER model, the best one available. But so you need to basically depend on those accuracies of those open source model available that you can use it.
So you're
And the other-
using a Hugging Face model
Yes.
for masking.
Yes. So the primary reason why we want to mask is we don't want to send this information to LLMs, right? So the other way you look into is probably you can download an open source LLM itself, and then use open source LLM to do this masking information as well. Or else you can take probably some pre-trained model and train it on your NER target system and make it more accurate on your data set. And now you have an NER model which is more accurate on your data set, and plug in to the system and plug into the connected to LlamaIndex. And so you can have more accurate on your own data set, whatever you're deploying for. Any other question I need to take?
Is there a limit to the number of documents LlamaIndex can load? Like what is the time taken to load a large number of documents, say 100,000 documents?
So I have shown so at the in-memory vector store index. So if you're storing like let's say 1,000 or 2,000 page document and making it in memory index, it will take a lot of time. But what in general people do is you store all these documents on your some other vector DBs, and then we have connectors. LlamaIndex has connectors to these vector DBs, all vector DBs available. And then so inside on the vector store wrapper, you need to basically have another parameter of use this particular vector DB based on your credentials, and then it will connect it to those vector DB and retrieve the documents and pass it to the response synthesis model to generate an answer. That's how it happens.
There's an in-memory index question, which the first question.
If I hear it correctly, models are stored in memory. Yeah, if the private data is very large, yes. Because we are mostly relying on the embeddings, it will take the cost is huge. And yeah, as I said earlier as well, the whatever demo I have showed, it's only on in-memory index, but you can index the same thing on Pinecone or Aviate or any other vector DB and then use it for your
There's a very fundamental question I read at the beginning, which is semantics is node and chunks are same thing, right? Chunking, what we call in
I because I just said chunk because we split the whole document into based on some splitter, and you create a chunk, and I call it the same chunk as node. That's it.
And one more question, this green question. Is there any way in which you can increase the number of relevant chunks that LlamaIndex will provide to a query?
Yes. So as I said in the start of the talk, like there is similarity top K parameter. By default, it is 1. So you can play with around 5 or 6, maybe 10 based on here the document.
Yeah, I think you will go back. We'll take this later.
Good. Next use case going forward is on text to SQL. So we have a lot of structured data in our SQL databases, and then
Sorry, can you just make it slideshow once again?
Is it visible?
मैं वो वापस जाना पड़ेगा वो कट रहा है this model. नहीं इसमें नहीं आ रहा the zoom is not coming correct. You'll have to press escape. Yeah, I'll have to do it like that. Okay, increase the section.
Fine.
Yeah, that's fine.
Okay, good. Yeah, so often we want an SQL query to be generated based on for user our own queries, the enterprise level probably. So a typical example is something like I have city stats data set being ingested into my SQL database, and I have a connector LLamaIndex as a connector of SQL to the database, and then you have an and then build an index and then start have a query engine and start having a query. One of the example which has the highest population in the city. The city has the highest population. So yeah, it generated query SQL, and then it uses a generated SQL query to the SQL connected database, and then generate a final answer. That's how it works. But again, in some cases, whatever answer I get, let's say in previous example, I got highest population, let's say, probably Bangalore in India, and I want to know specific information about Bangalore in India. And then, but my SQL database might not have all the those kind of whatever information about Bangalore I need. But I have a Wikipedia page data of Bangalore city. So I can use that information of Bangalore city information of Wikipedia page, and then try to generate an answer. How can you do that? So we have text to SQL and semantic search combination of query engine. What it has is we have SQL query engine as I shown, which connects to your SQL database, and then we have vector database as well, where all my Wikipedia index document is being indexed. So when I ask some query related to Bangalore city, let's say, what give me some famous breakfast places in Bangalore, which give me famous breakfast place in city which has highest population in India. So the first query is what is the highest population? I mean, city in India first of all. That is given by the SQL query engine. And then once you have Bangalore as an answer, so the next question is what are the other things like famous breakfast places for these things that you can get from your index document of Wikipedia, and then the final answer is being generated. So in that way, so you can connect both SQL and vector index documents, and then get a final answer. So yeah, you want to take some questions or?
Yeah, there are 1 to 4 questions. Can you just look at the Q&A? I think it will be easier, some of them are long questions.
In case of document search, can we guarantee or ensure through chunking strategy and key tweaking that the whole document is read through and answers to complete rather than the part? Yeah, this becomes an interesting thing. So it goes for your own document based on your iterations. What is the top K value you need to iterate over and then get the most premium one. That's how it works. And my source content is of different importance weightages, embeddings, or even some LLM bases would be as embeddings and appropriate weightage. I want the LLM to use this importance weightage as it seeks to answer a new question. I actually couldn't get Ashok.
Yeah, maybe Ashok can ask this question.
Or do you guys have any questions before going to evaluation? Yeah.
After masking the question, while putting it in the LLM, do you also unmask it as it might be important for the search side?
You mean once you get an answer, how do you unmask it, right?
Do you want?
Yes, yes. So once, yeah, I think I should have mentioned. So in this node processor,
You have to remove the children.
sorry. so when you use the node processor, it will mask. The output will be the masked sentence, but it will give a mapping as well, wherein your name is this and your place is this and all. So once you get a response from the LLM, you can demap it. Yeah, you can replace the name with the corresponding actual name and then give to the actual answer to the user. That's how it works. Any other question?
So, Ravi, so you said internally use LLMs for a lot of queries, right? Doesn't that add a lot of cost overhead for a single query that we do?
So there are two things. One is your embeddings cost. Okay, that is one-time cost, and chunking your whole document and creating embeddings for each chunk or node, whatever I said, is one-time cost. And then for user query, creating embeddings, it's a repeated cost for every question the user asks. And then based on your tokens of each chunk or node, the cost increases. If you use top K really high, like 20 or 30, and it will take those many LLM calls or token calls. I mean tokens basically.
So even if I choose, let's say, top case one, but the use case that you showed where we had joint SQL and text queries, or you like refine like answer and refine stuff. So every single so for basically one user query, you're making multiple LLM calls.
Yes,
right?
yes.
So that's what I'm talking about. Like for one query, you'll have multiple calls.
Yes. Yeah. If the structure, the stack you maintain is complicated like SQL plus VectorDB, yeah, your LLM calls increase and then cost also increase accordingly. But again, you can even there are default prompts available, but you can even optimize the prompts and then include them in the service context module. And probably if you have better prompts, then you can reduce the cost as well. Is nodes presupposes on the seeing for different kinds of resources. Once you're probably you have a document and the nodes are being created once, probably you want to you let's say the original document has 100 pages and you have chunked it and stored in the vector index, and then you get some more, let's say 10 pages by the end of next week. You want to add these 10 pages of the document to the index. You can add them. You can again chunk them those 10 pages and add it to the index. So you don't have to repeatedly index the whole 100 plus 10 pages. If I have private data, how can I use LlamaIndex in the embedding? Yeah, so as I've shown in the open source model version, so you can use an embedding that is hosted on Hugging Face, and yeah, and then accordingly build the whole process. You don't have to be always using the OpenAI embedding. Is there anything you are doing to tackle unconscious bias? No, unconscious bias, nothing here. Probably you need to handle, if you are facing that issue, probably you need to handle that with your own prompts, maybe. Is there a way we don't save raw text and simply save the embeddings that will help us search in private? I think some of the data vector DBs allow storing only the embeddings and corresponding node number, and you don't have to actually store the whole text in the vector DB. Probably you can have that separate mapping, and when you retrieve based on the similarity of the embeddings. You retrieve the node IDs, and you internally have your node IDs and correspondingly retrieve them and then send it to response in this model. That's something you can play around with. I think we are good to go. yes, you're probably 10 lines or 15 lines or maybe 20 lines of code, your LLM app is ready. But the interesting thing is whatever answers I get using LLamaIndex LLM to LLM calls or instances, are they giving the correct answers for based on only the documents, or is it hallucinating, or maybe it's not even related to the query the answer is not even related to the query I asked. So it's very interesting to have an evaluation of these systems before taking it to the production, right? So that's where one of the module, evaluation module in LlamaIndex helps you. But before one way is to take your system to the prod and use this evaluation module. Like you have a query and there is an answer generated, and probably use this evaluation model whether this answer is correct or not, and then take and based on the correct answer, right or not, you can give it to user. But before that, even taking one of the question is how can I even choose similarity top retrieve chances 2 or 3 or 5 or maybe 10. So before so let's say you want to have user have this on a document, queries on your on a specific document. What you can do is you provide the document to LlamaIndex, and then the first stage is you don't know what kind of questions the user asks. So and you yourself can't write like 100 questions and then give an answer, take an answer, write an answer manually, and then create a question answer pair basically, and then ask the framework what system you have developed to make an evaluation. Rather than that, yeah, we have created some question one, the first module, the question generated module, wherein you index your whole document and then let it create the questions. What are let's say you want 20 questions or 30 questions or 100 or 1,000 questions. So based on your given document, it will generate all the three. Let's say I asked here 3 questions, so it generated 3 questions here. Once you have these 3 questions, these 3 for an example point of view, we have 3 questions. You have 3 questions, and now I have an index which is which I have indexed earlier. Now I use the index and then each of these questions, and then ask it to generate an answer. Now I have question and an answer pair, which in real time probably these questions have been asked by the user itself, and you already have answers for these questions. And then then we have 3 kind of evaluator models. One is response evaluator, and the second one is query response evaluator. The third one is source context response evaluator. So doing the first one, I have query and then I have an index, and then once I index query the index, I get some response where it has a final answer as well as response source. Let's say you have top 3k or top k equal to 2. I have 2 source nodes information. What we can do is one way is I have this response text, and then I have 2 source nodes information. Are these actually matching? Are these in similar lines or not? So if the LLM says yeah, they are in similar lines, then there is less chance of hallucination or less chance of going out of the context of whatever context you have provided to the LLM along with the query to answer. So if it matches, it says no. If it matches, it says yes, sorry. If it doesn't match, it says no. And we have 100 questions like this. So let's say for most of them, it's like 99%. It's yes. Probably you might be sure that it will be your system is accurate. Take it to production. And the second one is query response evaluator. Often there might be some, let's say I have asked something about Bangalore city and it gives some information, but the document, the source nodes information actually doesn't have that information, but it might have hallucinated as well. But if you ask, let's say I have this query from user, and then this is some answer we have generated based on the source information, does it really answer the query? And I mean, the answer generated is based on the query itself or some random answer. So in these cases, yeah, if you want to use query and then response and then source node information and ask it to evaluate either yes or no. This is other way of doing evaluating the stuff. And the third one is source context evaluation. So I let's say for a given query, I use three source nodes, source of chunks or nodes or source of information to answer my query. I want to show to the user the second only one of these exact source from which not one, even multiple source of nodes from which the answer has been generated. Let's say my answer has been generated only from the source node 2. So I want to show to the user this is the only source of information that is being used to generate an answer. So what it does is internally it uses query response evaluator module, and then okay, this is the query, this is the source one information on the and also the response it has generated, whether these all these three match inline or not. So if the answer is no, that means this is not the source information that is being used for your generating the answer. So for the user, you can only show the source node 2, which is the most relevant one, rather than showing source 1 and source 3. That's how the evaluation model works here. So yeah, LLamaIndex, one of the company Albus from Springworks, they are using LLamaIndex for having question answering system on Slack channels for HRs. They can upload the documents, or maybe they can have internal documents indexed automatically on the fly, and then start having the questions. So they have used evaluation module, and then yeah. So for one of the question here, how many paid leaves are employees entitled to give? So it generated an answer, and then it just gave only the one of the source node which is present, rather than giving multiple source nodes from which the answer is being generated. And then yeah. This is a workflow. There is user query, and there are index documents. There is response with the source information or node information, source nodes, and you pass the source node all this information to the evaluator model, and then get whether it's a valid source information, which of this is valid source information, or is the if the response itself is valid or not.
There'll be one question which is there is how do you check the quality of the evaluator? The evaluator itself is asking, this is like the last question at the bottom.
Generally, for you, where the error is even wrong, because then is there any way to turn off the evaluator? So so we didn't benchmark it. We have done on couple of documents or how accurate it is. So for evaluation, by default, it's better to use GPT-4 because that is more accurate. And we did not benchmark any of these things, only on internal things we have used. But what you can do is use this evaluator as I shown in the earlier slide. So probably they have added an thumbs up and thumbs down thing. So for this source node information, whether it's accurate or not. So once you go live, maybe probably most of the users are seeing that it's perfectly all right. Maybe you don't have to switch off the evaluator as well. If it is going wrong for too many users, probably you can have it. You can turn it off. Yeah, and Jatin from RAGs, they are working on with integrating more evaluation systems to LLamaIndex. Probably some months down the line, you'll be seeing much more evaluation systems in LLamaIndex. Finally, we have how can you make LLamaIndex in productions systems. So there are different guides available, and also some certain collaborations, interesting collaborations. So when you want to build a full stack web application with LLamaIndex, at the front end is React or TypeScript or any other thing. They have guide for that, and then you can deploy and monitor your LLMs built on LLamaIndex with VLM as well as a platform. And then even it has tight up integrations with Ray platform as well for productionizing the LLamaIndex things. And yeah, we since there are a lot of things on OpenAI function side, so we have OpenAI Pandatic program that you can look after to get a structured output for your user queries. And there are a lot of integrations with the ecosystem. As I said, there are 100 plus data loaders available. We are still trying to integrate whatever integrations are needed by the enterprise companies or users, and then integrate into the data loaders on the Llama website. And even there are a couple of right now people are not only relying on the embedding retrieval, but even hybrid search as well, or maybe keyword search as well. So custom retrievers are also possible with hybrid search systems on inside LlamaIndex framework. Yeah, more or less is that's it.
Any questions, guys? There's a bunch of questions. I think I got Ashok's question. He's basically saying that can you assign different weightages to different embedding sources? So let's say you have a website and you have a book and you have an internal document. And then internal document you believe is obviously the right. So you give I want to give sources which are coming with from internal documents. Chunks from internal documents have higher weightage versus chunks. So how is that possible?
I think probably there is something called weighted retrieval module inside LlamaIndex, but not specifically for this kind of use case. But you might need to modify the weighted recency module a bit and then use accordingly for this use case.
Is there some sort of integration with LlamaIndex and open source models? Like again, this is a question on which is the most effective open source model which people have used. This is a technical question.
Personally, now which whatever companies LlamaIndex has been using, they are using I like Anthropic or OpenAI or Cohere models. No one is using open source models as of now because of the memory issues or production issues or maybe reliability as well. No one.
This is a question for audience. Has anybody here actually used open source models?
So I've tried Orca Mini, the recently model released by Microsoft Dictionary.
They're doubting
Uh, so-
Has anybody has a good experience with open source? Sorry?
I also tried way long back. So yeah, I mean, like deploying on Sage if there was a nightmare. So I just
Deployment is a problem.
Yeah, but parts of it, like parts of the whole process you might be using open source models, like let's say probably for embeddings, because they can be directly deployed on Hugging Face, or maybe like someone asked for personal information masking. Those models can be deployed easily. So parts of it you can use open source models, and parts of it you can use the OpenAI or Anthropic or some other available LLMs.
I think one other question is does LlamaIndex provide any sort of framework to tackle unconscious bias in LLMs?
I actually, probably you're not there. Yeah, I actually already answered.
that. It's already covered.
Does the quality of embeddings also vary across LLMs? If I generate embeddings with high quality LLM like GPT-4, but then for Q&A or open source model, vice versa, use low cost embedding model and then use OpenAI for Q&A. Yeah, so so when LLMs is only they don't by default LLMs is not used for embeddings. You have OpenAI embeddings that by default LlamaIndex uses OpenAI embeddings, but again you can throw off OpenAI embeddings and use sentence transformers as embeddings module that are shown in the open source GPT for all demo. So you can plug in sentence transformers open source embeddings for retrieval systems and then use OpenAI for Q&A. Yeah, the way you mentioned for case 2. So use that text right. I didn't so but OpenAI embeddings also use the text yeah, I mean the text 002 whatever it is open, it's the OpenAI embeddings, that's what I mean.
Folks, any more questions?
Yeah. So like on the router side, right? So you gave an example of like where for summaries you can use the list index, and if you have a specific question you can use the vector index.
Yes.
So how do if I have a collection of like books, how does the router actually retrieve? Okay, for the list index I have to use like n number of like nodes, and for summaries I can just pick one or two. Is there any logic that picks the node?
Can you
repeat the question for the audience?
can you repeat?
Okay, yeah. So for the query router,
Yeah.
you gave an example of like if of books.
Yes.
So I want to summarize a book, I can use a list index. If I want to ask a specific question, I can use the vector index. So like if I have a collection of different books, is there any way that look, I just need like only the notes related to the books for the list index, right?
Okay.
So like does the router also filter that out, or how do I filter that part out?
So if you have collection of let's say 10 books, and then so how it works is by default you need to you create a list index and you say yeah this index as a summary can answer questions related to Harry Potter book, or else maybe has this index is list index that can be answered only useful for summary queries related to Harry Potter. Okay, and you have book 2 as well that this has an index summary which has yeah related queries related to book 2, book 3, something like that. So when
You have books have individual list.
yeah indexes, and when you ask a question on query the router engine by inside it uses LLM. It by default it it classifies, basically it's a classification thing. You need to classify the query to one of the available books.
Okay.
And then once you classify it, so okay, this question is related to let's say book 1. I'll pass this question to list index 1 and then retrieve the document. Either you retrieve or you want to go through all the book, that's up to you based on the similarity of and then generate an answer. One more. For example, stock performance queries from the user can be relevant in different nodes, but inferences may not be based on historical, but key performance benchmarks that are industry-led or sector specific. I didn't actually get Vibha. Probably if you can speak, maybe I can answer on this stock performance.
Yeah, I didn't get this question either. So she asked, I think we were asking a question on stock performance queries for users, need timeline in different nodes, differences need not be used in study for There's one simple question I think right at the top. If I have private data, this first one.
How can I use
I want to
LLamaIndex?
repeat it for the webinars.
If I have private data, how can I use LLamaIndex using the embedding? Don't use OpenAI. Yeah, I think I have cleared it. You can use Sundex transformers of embeddings hosted on Hugging Face. That is open source model. So,
Yeah, I think the person is trying to do it without spending any money.
yeah, on Hugging Face, you don't have to spend any money. Yeah. So yeah, something yeah. So here I have included Sundex transformers embeddings here. So it's an open source. There is no cost involved. Yes. Yeah.
All right, cool. Thanks. Thanks, Ravi.
Yeah,
Thanks, guys.
thank you.
It's actually a past 6. So
I
thank
think
you,
we're
everyone.
on time.
Hey, hey guys, thanks for joining online. We have a bunch of people. Thank you for coming. We'll try to do these more often. So thanks a lot, and we'll close the session here. Bye bye, everyone.